In today's class, we're going to talk about the chain rule of differential calculus. The chain rule of differential calculus is used to differentiate a composite function. A composite function is a function that has another function in itself. There are two criteria that must be met before we can make use of chain rule. The first criteria is that the function must be a composite function. The function that we are differentiating must be a composite function. That's the first criteria. The second criteria is that this function must be differentiable. Are you getting it? So let's say we are told to differentiate a function that looks like this. Y is equals to 2x plus 1 raised to the power of 4. This is a typical example of a composite function. Are you getting it? So now, in order to differentiate it, the chain rule can be expressed mathematically as dy all over dx is equals to dy all over du multiplied by du all over dx. This is the mathematical expression of chain rule. Okay, let's try to differentiate this function. The first step is that I want you to note that we have two functions in this question. The first function is the inner function. The another function is the outer function. The first step I'm going to do is that I'm going to set the inner function is equals to u. Are you getting it? So let u is equals to the inner function. Look at this. The inner function is 2x plus 1. So u is equals to 2x plus 1. Are you getting it? So that's the first step. You're going to set the inner function is equals to a letter. In this case, I make use of u. You understand? So after setting the inner function is equals to u, then y will be equals to what? U raised to the power of 4, because I have set u is equals to what? 2x plus 1. And y is equals to 2x plus 1 raised to the power of 4. That means that y is equals to u raised to the power of 4. Now, the next step is that I'm going to take the derivative of u and y. Are you getting it? Because from the chain rule formula, I need the derivative of dy over du and the du over dx. Therefore, I'm going to take the derivative of u and y. Now, let us take the derivative of u using the power rule. Du dx, that is, differentiate u with respect to x. You understand? That is what is meant by du over dx. So, du over dx using the power rule is what? 2. You understand? So, I have taken the derivative of u. Now, let us take the derivative of y. I'm going to take the derivative of y with respect to what I have here. I'm having u, you understand, at the right hand side of this equation. So I'm going to have dy over du is equals to what? If you differentiate u using the power rule, you are going to get 4u raised to the power of 3. Do you understand? So we have differentiate u and y. Now let us go back to our chain rule formula. The chain rule states that dy over dx is equals to what? Dy over du. Dy over du is what? 4u raised to the power of 3. So I'm going to have 4u raised to the power of 3 multiplied by du over dx. Du over dx is what? 2. So 4u raised to the power of 3 multiplied by 2. Do you understand? So now, dy over dx is equals to 4u raised to the power of 3. That is 4 multiplied by u. U is what? U is 2x plus 1. So I'm going to substitute u is equals to 2x plus 1 into this expression. So I'm going to have 2x plus 1 raised to the power of 3 multiplied by 2. Do you understand? So dy all over dx is equals to 2 multiplied by 4. That is 8. That is 8 multiplied by 8 into bracket 2x plus 1 raised to the power of 3. Therefore, the derivative of y is equals to 2x plus 1 raised to the power of 4 is what? 8 into bracket 2x plus 1 raised to the power of 3. That is how to make use of the quotient and the chain rule of differential calculus. Now let's have some further work example. Let's say we are told to find the derivative of y is equals to sine 4x plus 2. Let's differentiate this function. You can see that this is a typical example of composite function because we have both inner function and the outer function. The inner function is what? 4x plus 2. The inner function is the function that you have inside the bracket. Are you getting it? So I want you to understand that the first step is that you are going to set the inner function to a letter. In this case, I'm going to say let u is equals to the inner function. The inner function is what? 4x plus 2. So I'm going to have 4x plus 2. So if u is equals to 4x plus 2, definitely y will be equals to what? Sine u, because I have set the inner function is equals to u. So the outer function is what? Sine u. Sine u. Do you understand? So now the next step is that I'm going to take the derivative of both u and y. I'm going to take the derivative of both the inner function and the outer function. So let's proceed. The u all over, with respect to what is here, I'm having x here, so I'm going to have the u over the x is equals to what? If you differentiate 4x plus 2 using the power rule, you're going to get 4. Probably you didn't understand how to differentiate a function using the power rule. Check the description of this video, you're going to see the links there. Okay, let us proceed. If you differentiate 4x plus 2, you're going to get 4. Now, if you take the derivative of sine u, don't forget, we learned that if we differentiate sine x, the derivative of sine x is what? Cos x, abi? And the derivative of cos x is what? Minus sine x. And the derivative of tan x, if you differentiate tan x, sorry, if you take the derivative of tan x, that is what? Sec square x, abi? So we are going to make use of this here. If you differentiate sine u, you are going to get what? Cos u. You understand? So dy over du is equal to what? Cos u. It's very important that you master this, okay? It's very important. Okay, let's proceed. So now, having differentiated both the inner function and the outer function, I can now proceed to make use of the chain rule formula. So dy, according to chain rule formula, dy over dx is equals to, let me put this in brackets so you don't get confused. Dy over dx is equals to dy over du. Dy over du is what? Cos u. Cos u multiplied by du over dx. Du over dx is what? 4. So cos u multiplied by 4. So dy over dx is equals to 4 cos u. So dy over dx is equals to 4 cos u. Don't forget that we have set u is equals to what? 4x plus 4. So I'm going to replace u as 4x plus 2. You understand? So I'm going to have 4 cos 4x plus 2. So therefore, the derivative of y is equals to sine 4x plus 2 is what? 4 cos 4x plus 2. Do you understand? Let's have another work example on chain rule. Now, I want to do something. Pause this video and attempt this question. Then, when you are done, play the video again. Then check probably maybe you got the answer or not. Now let's proceed. Y is equals to cos into bracket 3x minus 1. Don't forget the approach. The first step is that we are going to set the inner function equals to the equals to u or equals to any letter. You understand? So I want to set the inner function equals to u. So I'm going to say u is equals to 3x minus 1. And I told you that the inner function is the function that is enclosed inside the bracket. The function that is inside the bracket, that is what we call the inner function. You understand? And at the same time, they might not put any bracket. Just know that when you have a function of a function, an equation involving function of a function, you are going to make use of this rule to differentiate such function, okay? So let us proceed. U is equals to 3x minus 1. That is the inner function. Definitely, y will be equals to what? Cos u. You understand? So now, the next step is that I'm going to take the derivative of the inner function and the outer function. So u is equals to 3x plus 1 du over dx. Don't forget, I'm differentiating with respect to what I have here. If I have t here, that will be what? Du over dt. If I have any letter here, I'm going to differentiate with respect to the letter that I have here. But I'm having x here, that is why I wrote du over dx. You understand? So du over dx using the power rule is what? 3. And dy over du is equals to what? Have you seen? I'm differentiating y with respect to what I have here. The letter that I have here is what? U. That is why I have dy over du. Probably if you have t is equals to cos z, that will be what? dt over dz. Do you understand? So you are differentiating with respect to what you have at the right hand side of your equation. So dy over du is what? If you differentiate cos x, what are you going to get? You are going to get minus sine x. So if you differentiate cos u, you are going to get what? Minus sine u. So for this, I'm going to have minus sine u. Okay? Now let us progress. Dy over dx now equals to dy over du. Now dy du is what? Minus sine u. So I'm going to have minus sine u multiplied by this multiplication sign. Is it du over dx? Derivative of u with respect to x is what? 3. So I'm going to have minus sine u multiplied by 3. So dy over dx is equals to minus 3 sine u. If you multiply 3 minus, if you multiply minus sine u by 3, you're going to get minus 3 sine u. And now recall that we have set u is equals to what? 3x minus 1. Therefore, I'm going to replace u as 3x minus 1 in this equation. So I'm going to have dy over dx is equals to what? Minus 3 sine 3x minus 1. You understand? So the derivative of y is equals to cos 3x minus 1 is what? Minus 3 sine 3x minus 1. So now